So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own Mascota this side. So welcome to lecture number 19 of the binary tree series. The problem for the day is k-sum paths. K-sum paths. The problem is actually very beautiful and you will love to solve it. The problem says that you haven't given a binary tree. This is the root, of course, right? Now it wants you to return the number, mind it, return the number of paths such that their sum is equals to k. K has been given you as an input, right, and the root has been given you as input. What do I mean by number of paths? So number of paths is start node up till end node such that, mind it, such that the start end node is in downward direction. That is, if you see this node, start node, end node, this is a valid configuration, but start node, end node, this is not a valid configuration, right? They have to, like, the end node have to be a descendant of a start node, right? Okay, now how to solve it. First, let's see the example test case only, right? So for the given tree 1, 2, 3, 4, 2, suppose the k is given to you as 4, right? What are the answers possible for it? So I can say that I can pick these two nodes and that will be my one of my answer, right? So 1 and 3 is a valid answer. 4 alone is a valid answer, right? 2 and 2 is a valid answer, right? Okay, so these are the three cases I am able to see. So the answer for the problem is 3, right, for k equals to 4. Right, I think that you have got the problem, that you have to return the number of paths, that is start node to L node, and end node should be a descendant of start node, right? That is 3 plus 2 5 is not a valid path. Okay, 3 plus 2 plus 1 plus is equals to 6 is also not a valid path, right? Now how will you solve it? The problem arises, how will you solve it, right? So let me make the tree here again. Okay, so this is a tree given to you. Now we know that start and end have to be descendants, right? End node have to be the descendant of start node. So if there is a sum, suppose I get to 1, I will compare it with my value, right? I will compare it with my value. This 1 plus 3 will give me 4. See, here the sum is 1, here the sum is 1 plus 3 4, here the sum is 1 plus 3 plus 4, that is equals to 8, right? Okay, so 1 plus 3 4, 1 plus 3 plus 4 8. If you see from some values, you can see that only this sum is matching, so I can say that count equals to 1. But we still incomplete that 1 comma 3 is also true and 4 is also a valid path, right? So we just don't have to see the current value of the sum. If I take the root value to be 1, that is, a sum here will be 1, some here will be 4, some here will be 8, that is not giving me a correct value, right? Why? Because if you see, at 1 I got the 1 value, at 3 I got the sum as 4, at 4 I got the sum as 8, right? This was correct. This was correct because 4 I need and 4 I got. That means 0 is somewhere here, 0 is somewhere here where there is no node, right? So what I can do is, I have a 0 in my hand, I can say 4 minus 0 is 0, so increment it. Now, what if there is an 8 and there is a 4 also? So you can say that this node itself, if I exclude this path, then this node itself is also giving me 4. But how do I count it? So here comes our map skills. So if we have a count that I have encountered 1 right now, I have encountered 4 right now, I have encountered 8. For 1, I can say that 0 is existing beforehand only. I can say for 1, 0 is existing, but 1 minus 0 is not giving me 4. So 1 is not giving me anything. 4 minus 0 is giving me 1, correct. 8. Now I need a value of 4, right? So if I have the x as 8, sum is equals to 8, right? I need 4. So how much do I have to subtract from it? 8 minus 4 equals to 4. If I have the value 4 in my current map, that is from 0, 1 and 4, I can increment my answer. Right? So what I can say is 8 minus 4 equals to 4. It is present. One time it is present. So I will also increment my answer by one time. So what is actually happening? As soon as it comes here, it will see 8. It will say that 4 is actually contained in the path. 4 is actually contained, so it will return 1. 8 is going to return 1. 3 is saying that 1 is coming from downwards. I am also returning 1, so I will return 2 to it. Okay, one will say, okay, right tree is done. Let us see the left tree. Let us see the left tree. Now, mind it that when you pushed 0, it was starting. This 0 is like universal. Okay. Then when you came to node 1, you pushed 1. When you came to node 3, you pushed 3. When you came to node 4, you pushed 8. But when you're going back from 4, you need to pop it now. You need to pop it down. Why do you need to pop it down? Because you want to prevent these nodes using this 8 value. That is why you need to pop it down. Again, as soon as you return 3, pop it down. As soon as you return 1, you are not returning 1 right now because you are going here. So 1 will go to 2. Now some will get 3. So you will push 3 here. Some will get first for 3 you will check is 3 minus 4 minus 1 exists in the map. No, minus 1 doesn't exist, so value will be 0 right now. Then go to 2, then go to 2, 5, some will be 5. 5 minus 4 is equals to 1. Does 1 exist in the map? Yes, 1 is existing in the map, so push 5 first and then you can say answer equals to plus plus. So return 1, and after returning 1 just pop it out. After when it will see 1 is coming from this side, return 1 and pop out 3. It will say 1 is coming from this side, 2 is coming from this side, return the sum of them 3 and pop out 1, right? 0 will not be popped out, 0 is universal, right? 0 is universal. So I will be saying my answer to the question is 3. Okay, so let me explain again what did we do. This was a tree, right? Let us say because I need to check the values of if this exists or not and how much time this exists, I will be using a map, right? Suppose this is my map. This is my map. So what is actually happening? I am coming to 1, right? I am coming to 1. Okay, so I will say 0 is equals to 1, 0 map to 1, right? This is a universal, so I will just say 0 maps to 1. I come to the root node. I say let us explore the left subtree first. Let us explore the left subtree first. First, check the value. Sum equals to sum here comes equals to 1. See, sum equals to 0, it will change it to 1. It will change it to 1, and I will check if 1 minus 4 which is equals to minus 3 exists a map. No, it does not exist. So answer will remain same. Answer will remain same. It will go to 2. 2 will say sum I encountered sum equals to 1, but I will say now the sum is equals to 1 plus 2 3. 3 minus 4 equals to minus 1. Does this exist in the map? No, it does not exist. So, okay, go to forward. It comes to 2 here. Sum equals to 3 was given to me. I will change it to 5. Now 5 minus 4 equals to 1. 5 minus 4 equals to 1. Does it exist? You will say yes. 1 was existing, 3 was existing. 1 is existing as a counter of 1. So I will return 1. I will return 1. But before returning, I will say 5 is 0. So if it was 1 here, it converted it to 0. 1 will say it is coming from down, it is coming 1. So before returning, I will change it to 0 again and I will return 1. 1 says, okay, I get 1 from here, but now explore the right subtree. I have not yet returned the 1, so I will not pop 1 out, right? I will come to 3. I will say that I encountered the sum of 1. I will change it to 1 plus 3, 4. And I will say that 4 minus 4 exists. 4 minus 4 exists. Yes, it exists. So my answer will be 1 in my hand. And I will get the value from the downwards. Also, 4 value will be changed to 1 here. As I come here, sum given to me is 4. You can see this 4. Change it to 4 plus 4, 8. And I will say 8 minus 4 equals to 4. Does 4 exist? Yes, 4 exists. So I will also increment and I will return 1. Before it will change to weight to 1 and then it will say 0. It will say 0. Again, it comes 1. It says I had already 1 in my hand. I got 1 extra. Change my value to 0 and then go above. Go above. As soon as it go above, it will see that it is returning 2. 1 plus 2 returns 3. I have to return 3, but before returning, I will change it to 0 and my answer in my hand is 3. That is my current answer. That is my correct answer. So what I am actually doing is I am making a map, another map also, that it will be another map to save the complexity. Let us name it as np, right? I'm making a solve function which is taking some parameters. What are the parameters? I need the root, I need the current sum. I have declared map as global, right? First case, if root equals to null, nothing possible, right? Nothing possible. Just return 0. Just return 0. Otherwise your value is gonna be 0 right now. Now sum plus equals to root data, right? Value plus equals to mp of sum minus k. What is k? K is given to as input, which we require the k sum path, right? After that, well, this will be value plus equals to solve for root left. Also, before going to root left, MP of sum plus plus, right? Okay, solve for root left with the current updated sum. Similarly, value plus solve for root right with current sum. And now MP of sum minus minus, right? Because we just going to return, so before that decrement it and then return the value, return value. This is the only code you need to write, right? So what is actually happening, we just increment the sum as it come to a root. We just checked that if it exists, so increment the value of the current sum, then get the value from the right and the left, and then decrement before going to before returning, and then return the current answer you get, right? This is the only code you need to write. Hope you're clear with it, and it is time for you to see the code. Hope you're excited. Here is the coding section, guys, but before starting with the code, it's my sincere request to you, please subscribe my channel because it really motivates me, and I will bring out more such amazing content in the near future as well. So it is very simple. I just have to create unordered map to store the count of the sums. So unordered map of int to int, and name it as MP, right? And then just say return the solve function, which is a helper function I'm going to make, and send the root there, send the k there, send the sum there along with the MP, right? Let us implement the solve function. So int solve, which is taking my node star root, int k which I require, int sum which I require, and unordered map by the reference. So unordered map of int comma int and MP, right? Now what I have to do, if my root equals to null, I cannot do anything, return 0 simply, right? Otherwise change the value. So sum plus equals to root data and int value which I'm going to return equals to 0. First value plus equals to MP of sum minus k. If it exists, increment. Also before sending it, MP of 0 has to be initialized by 1, right? Because we just discussed it that MP of 0 is gonna be 1. 0 is a universal value, right? Now MP of sum minus k. After that, what will you do? You will just increment the MP of sum that it exists in the current descent, right? Now value plus equals to solve for root left with k, updated sum and MP, and similarly value plus equals to solve for root right, solve for root right with k, sum and MP. At last, before returning MP of sum minus minus, because the descent has been done for the current node, and then return the val, right? It will run fine, I guess. Let us try to compile and run it. Hope it will work fine. Okay, it is giving some error, unordered. Okay, the spelling has been mistakenly typed wrong. Let us try to compile now. Please work fine. Again an error. Sum was not declared in the scope. How is sum not declared? Oh, okay, I will send 0. Right, I'm not sending it by reference, so I can just send 0. Okay, it is working fine for the sample test case. Let us try it for the backend test cases as well. It is proceeding and it is running absolutely fine, guys. As you can see, the counter is going up and okay. So thank you for watching. Hope you liked it, and we'll meet in the next video. Till then, stay tuned and keep coding. Thank you. Have a nice day.